So hi everybody, my name is Lance Evans. I'm the Chief Storage Architect in the HPC division of HPE, formerly of Cray, acquired by HPE January of last year. And I'm here to talk about HPE's DAOS solution plans. And this is decidedly non-technical really, because I stand on the shoulders of giants. It's clear that there's been plenty of technical work and it's ongoing. We've certainly done our own benchmarking and a lot of work inside HPE, but this is really all about taking the science project and turning it into product gradually over time. So what we did was we engaged in a research phase that was roughly ran about 9 months at HPE and wrapped it up around the third quarter of 2020, so not so long ago. The goal was to prepare HPE and prepare our storage division, HPC storage division, for emerging storage hardware, the persistent memory, using HPC capable data path software like DAOS. We think, of course, that there's a next gear that we need to achieve in order to get past the latencies and issues of traditional parallel file systems. So we evaluated DAOS architecture. We looked deeply at the code quality, its maturity, the development team's complexion, and the processes they used. This is a long-term prospect for Cray HPE to adopt a new data path like Lustre. And so we wanted to make sure that everything was headed in the direction that we believe it needed to be. And also to consider related IP that may compete with it or complement it, maybe dovetail into it or contribute to the code base, and maybe new design techniques or new approaches to things that we might want to contribute to the code as it goes on. And then recommend a path to our executive management and our product management organization for this next generation HPC data infrastructure. And the good news is that the outcome from management was to proceed with solution prototyping and technology transfer from the CTO office, which is, of course, where I work and where this project is being run from, and then do that technology transfer into storage R&D for later productization. So that's the phase we're in right now, and this is what I'm here to talk about today. So I won't really belabor this a whole lot, but the goal really for us is to enable the very smallest configurations with the very lightest touch implementation for the small systems, whether that's an AI or ML workload, or the largest systems in thousands of storage nodes and tens of thousands of clients. All these traditional HPC apps we want to be able to support, gradually transitioning from traditional parallel file systems over time, running these things in parallel, of course. And then also to enable non-traditional HPC apps, which you're all familiar with and have been talked about earlier in the call. Finally, I think that there's a lot of potential here in the long term. You know, if you're thinking about 10 or 20 years on a data path, the transaction support that's being introduced and additional features really gives us new opportunities for being a bump on a wire for streams processing, or database and graph analytics, those kinds of things. And of course, computational storage, which is something that's emerging as we speak. So the reference implementation goals were to harden the data path software, targeting the version 2.0 DAOS code base. And so we're looking at something in the time frame of the third quarter of 2021 for our initial solution release. Bundle it with released HPE hardware and customized Cray management software. So we manage some pretty big machines. You know, we write management code for some pretty big machines. We want to incorporate that functionality into this solution so that we can have a vertically integrated platform, but also that can be shipped independent of any Cray supercomputer. So if anybody wanted to attach this to any cluster, they could. We want to enable initial customer deployments with repeatability and low risk. We don't want people to have to understand a lot about DAOS to get it installed and get it running, and making sure that the network drivers are proper and the configuration of the software itself is suitable to achieve the appropriate performance on our HPE hardware, and then also prepare the organization, the R&D organization, for a subsequent productization step if the trial period is successful. So what does this look like? It's on the left-hand side. This is an Intel Ice Lake-based platform with DCPMM and NVMe devices. This is a dual-socket Ice Lake platform that we'll be releasing next spring. 16 DIMMs per socket, and 16. It'll take more than 16 SSDs, but we'll balance the I/O from front to back, and then insert NICs in there. On the right-hand side, we'll be using some pizza boxes from the PerLiant team as well for system management. We'll be able to offer redundant management servers, HPE Aruba management switches, more HPE product for the management path, also redundant, and then Mellanox 200 gigabit Ethernet or HPE Slingshot 200 gigabit. I'm sorry, Mellanox 200 gigabit InfiniBand or HPE Slingshot 200 gigabit Ethernet. And that's the HPE product. But customers who want to run InfiniBand or want to run a generic Ethernet network will also be offering that. And then we'll be offering a solution that removes those switches if you just want to direct connect the DAOS nodes into your own fabric. So what does that look like in a nutshell? We have 16 nodes, a single rack solution. We anticipate shipping initially, it's these DL380 Gen 10 Plus servers, up to 16 of those in a configuration with up to 4 InfiniBand or Slingshot switches, and the management infrastructure at the top. What we expect to be able to achieve is about 1.4 terabytes a second, or writes, and 700 gigabytes a second estimate raw write throughput. 100 million write and 50 million read IOPS is the estimated max. The hardware will do significantly more than that, but software latencies and inefficiencies will limit us probably to that range. There's some significant performance tuning work that we need to do between here and next September in order to achieve those goals, but we think that that's doable. This will be an unbundled, repeatable solution delivery method. This won't be a full productization into our cluster store product line, but we will provide a qualified hardware and software BOM with installation and configuration framework software and scripting wrapped around it to make this repeatable and supportable. A reference doc set for those areas that are still a little bit raw. We don't anticipate, for instance, putting a GUI on top of this thing at this point. We want to get it out there into customers' hands and get some feedback on these early DAOS releases. And customer system administration skills will be required in order to do this, but hopefully we'll ease that path and we'll be providing engineering support to that small set of customers. We are seeking early adopters for package trials in the third quarter of 2021. The individual components will be sold individually. We're not going to have this large product SKU and go through that whole configuration process. Productization at HPE is a very serious thing, and it takes a significant amount of time to work our way through those steps. We want to make sure that we have everything dialed in just right by the time that occurs. We'll be providing the DAOS solution scripts and engineering collaboration on their operation and bug fixes, etc. So it won't run through the normal support organization, and at least initially. And then our full HPE DAOS product pacing is TBD, but we do anticipate moving to that step if these trials are successful. What's next? Let me see. I've got, so what's next for us? Our results so far lead us to believe that DAOS is a viable alternative data path to Lustre and data path for future HPC storage designs. Our use cases are widening. It's not just traditional simulation anymore. And of course, the hardware is changing and we need to adapt to that. and DAOS looks like a really good fit there. Of course, our HPC division, formerly Cray, will be participating with Intel as a subcontractor in delivering the Aurora supercomputer to Argonne. That's one of the largest computers in the world, and it's going to contain over 200 petabytes of DAOS. Now, that's an Intel deliverable, but what we'll be doing is helping integrate that into the Aurora supercomputer. Our lab will also host a small number of potential customers between now and next September who would like to run POCs. In our test bed, we've got a test bed very similar to some of the test beds that were shown in earlier slide presentations today. And we'd like to bring in a small set of those customers who want to kick the tires on the product without having to build up their own environment. We'll also collaborate with those early adopters, integrating these working DAOS solutions into their environments, getting product requirements and getting feedback from them. And then, assuming this trial phase is successful, we intend to proceed toward full productization of DAOS roughly in the Sapphire Rapids timeframe. So that's sometime in 2022, and that's when we would get the full Cray/HPE productization that you would expect from ClusterStor. We think that combining our scalable HPC system management, our server designs, the HPC server designs from HPE, and the Slingshot networking, we think we can offer the most scalable and performant storage for the world's largest supercomputers and also for your systems as well. That's really it. Please feel free to contact me if you'd like to be involved in a customer POC or if you'd like to kick the tires on DAOS. Thanks, Johan.